Hey, this is Bill. I'm checking in with Paul McWhorters' Pico W class homework for lesson 41. Still working with the MPU 6050 chip or board that is a microprocessor that is an accelerometer, gyrometer, thermometer. It does a few different things, and it's works in the X, Y, and Z axes, both directions. So I guess that they say makes it a 6 degrees of freedom. Um, I'm probably starting off in a bad place because I'm going to explain what I thought the homework assignment is. Paul wanted us, the way I interpret it was Paul wanted us to take the gravity units that the accelerometer was displaying and change it to a more quantitative value, which and then he threw out the idea of pitch and roll and that kind of stuff. And so I used to own a Toyota FJ, and it had an inclinometer on there, and that's what I was trying to represent with that green piece of paper with kind of a bullseye circle on there, or a sight circle there. And the way I have it on there is if we were going up or down a hill, then this little ball gimbal type thing in there would move, and so this like 10 would line up with this line, and you'd say, okay, I'm 10 degrees. If we're going the opposite direction, or tilting backward, then we would have this 10 degrees. Also, if we were on a side hill, this 10 would line up with this 0 point, and so we'd be 10 degrees off. If we were tilted the other way, that would be 10 degrees. And so that's what I was trying to represent with the MPU 6050. And I hope I'm after the right thing. Okay, so essentially what we do, a lot of the usual suspects, we have to import the I2C bus or component, I guess. And we need that for the MPU chip, and then I also threw in the SSD because I know we're going down that road, the SSD display. And we're using the GPIO pins, and so we've got to call pins, import time, and then another thing that we need to do, because I'm actually going to be using some of the trig that we've been going through, and so import math. So here we go for the MPU. I used channel 0 on the I2C and used the SDA pin 16 and 17. On the OLED, I used channel 1. I used pins 14 and 15, and then you put in the parameters for the number of pixels in the display. I print out a lot of stuff, and I'm going down where I think we're going to be, and so we can just disregard all this commented out stuff. Go down while true. I start out and I have this display fill 0, and the reason why I'm doing that is as it loops through the while true, it'll clear the display, so the values that you see down here moving on the serial display, you can see where it's going through roll and pitch repeatedly, every 0.2 seconds, in fact, that won't get just jumbled up and turn into a mess on the SSD display. Okay, so what I did was I used the x-axis for roll and the y-axis is pitch, and we can look at both of these pretty much the same because they are the same. The Thani or the Pico likes to work in the world of radians, so we've got to change this to degrees, and so that's 360 divided by 2 times pi, and so the math.pi gives us that. And you remember the circumference of a circle divided by the diameter gave us pi, so do a little bit of arithmetic. So the circumference of a circle is 2 pi radians, and so we're just changing it to 360 degrees. You know, I always thought 2 pi radians was kind of goofy, but that makes a whole lot sense, or makes more sense to me than 360 degrees. It would be more curious to find out why 360 degrees was chosen than 2 pi. But anyways, I digress. Since we're trying to figure out the degrees, we're kind of going backward, and so I use the arc sign of the accelerometer reading to turn it back to a degrees sign. Oh, this 3 at the end goes along with the round. I was trying to round it off to 3 places past the decimal, although if you watch, you can see down here, it doesn't do it all the time. Like right here, we've got a lot more, and if you watch it long enough, you'll see it'll do it on the pitch side as well. But anyway, I'm not sure why that is. And so it's going through and doing that, and you can see, let me move this up. You can see that's what it's doing. I hope that is clear, but you can see as I change pitch and roll, you can't really read that as I'm moving this all around, but it's on the serial display, so you can see that. So I think we're accomplishing stuff. There's one thing that I kind of ran into a little bit of problem, and that's if you go too far, things kind of lock up and you get this value error, math domain error, and I looked that up. Excuse me. And that says that we went beyond the bounds of 1 and -1 for the sine. Oh, I should back up a little bit. I use sine for both of these, and the reason why is because I'd be 90 degrees off if I used cosine, which for some reason I always kind of think of the x-axis as a cosine, but that would be off. And you can see down here that you know, I've got negative numbers depending on which direction the pitch and roll are going, although there's no negative represented on the inclinometer. It kind of is, you know, because you can see if we're looking left and right, those would be different, or up and down, and that would be different. I just left it so it's negative, and I think that's going to come into play, something that we need down the road. Anyways, hopefully I understood the assignment correctly. If I did not, or I'm missing what Paul assigned, let me know. Okay, see you next Tuesday.